wonderful world of math videos like in YouTube cyberspace land. Yes. Hey, my name is Mr. Wara. I will be your host for this evening, so please buckle up. The ride could get kind of bumpy. No. Hey, all seriousness, let's get going, my friends. Um, Look at this. The objective is right there. Use divide by 10 patterns. This is something we've done before. Yes, we have. If you recall, we did a lot of that in the whole place value, and now we're building because little by little, I'll let you in on a secret. Just because I know what's coming, we're going towards division now. Yeah, okay. Shh, don't let anybody. Hey, don't tell anybody I told you, because you see, multi-digit whole number division. This power of 10 is going to play a part in us understanding how this all works. Anyways, we need a little bit of fluency practice here. Believe it or not, the fluency practice is extremely easy. I mean, for example, take the number 32. What would you round that number up if you had to round that number, right? I know what you're thinking. 500, right? No, I hope you weren't thinking that. No, I hope you were thinking 30. Yes, Mr. Wara, I was thinking 30. Okay, 18, we're talking 20. Okay, pretty simple. Yep. Because the kind of rule we use, 4 or less, let it rest, 5 or more, up the score, and, all those other little poetic rhymes. But what we are going to do is we're going to take it a little bit beyond that, because you're thinking, boy, Mr. Wara, for fluency practice, this is kind of easy. Well, let's go ahead and let's do the multiples of 3. Pretty simple. You guys know this is. Hey, look, Mom, I'm counting by 3s. Yes, except could you count by groups of 3, such as this, but using powers of 10? For example, 30. So now we're doing 30, 60. Okay, you get the idea. 90. Okay? So now this is where we're going to move it on, is up into the higher level. You could do the same thing by 4s, 40, 80, 120, 160. Okay? We're doing this fluency practice to understand that elusive power of 10, I say. Yes. Okay, next page. Ding. Okay. Anyway, here we go. What's this here? Whoa. You know what I just noticed here? There's a spider. He looks so familiar. Okay. Move on. So here it says, this is the application problem, and the application problem is basically the work that we've been building on and we've been reviewed, so to bring it into this particular lesson so that we can build upon what we already know. So this should be really easy, right? Well, here it says the area of a vegetable garden is 200 square feet. The width is 10 feet. Okay? What's the length of the vegetable garden? Well, what comes to mind when I think of a vegetable garden, I'm kind of thinking, since it's got a length and a width, you should be thinking shape. So let's do a shape. However, I don't know if I like black there. I'm going to see if I can't use another color, like something really bright. Ooh, line style. Ooh, let's do something like that. Yeah. Okay, so I know you're thinking, Mr. Wara, you're having way too much fun with this job. I know I am. This is really great because you know what? This is the math I love, the real problem stuff. Okay, so when we look at this, I'm going to come down with my pen, and I'm thinking, maybe since it's telling us the area, and the area is what's in the inside, just like carpeting in a house or in a room, so that lets me know that this is the area. So let's just write it right in there, make it really, really easy. Now we come back over here. Let's go ahead and put the width. They gave us the width, so let's put 10 feet there. Now what we don't know is the length, so put a question mark. Look at that. We're already on our way. My goodness, this is fun and easy. And okay, I think I already said that. So what we could do here is we can look at this and basically say, well, if the formula for area, which we do know is, right, area equals length times width, therefore, we could say 200, okay, square feet is equal to the length, which we don't know, okay, times 10. Or, in other words, since the length times width is equal to 200 feet squared, Well, the commutative property says that it doesn't matter what the order is of these two terms, we could multiply. So we could actually do the same thing when we divide. So we could take 200 feet, divide by 10 to get the length. I know, pretty sneaky. So I'm going to go ahead and do that and say that that's going to be divided by 10. Therefore, it's going to give us the length. Now look at here. Remember we were doing those powers of 10? Here we go. We have a power 10 here. Now, here's the nice thing, is that this is just divided by 1/10. This is like the decimal place is moving one place to the left when we divide by a power of 10. Or sometimes you just look at that and just say, hey, I'm just divide that by 10, divide that by 10. I still, length is going to equal 10. I'm sorry, 20. Where was I looking? Saw something shiny, I think, over there. 20 feet. So 20 times 10, again, is 200. So easy to make so many mistakes when I'm, blah, hello, bats. Now, moving on to the next page. I think that covered it, yeah? At least almost. So, moving on to the next page. Ooh, look at this here. Now, I would love to have a calligraphy pen. I like all those cool colors. Anyways, now we have 420 divided by 10. This is our concept development. So now we're going to start to apply what we just did in our last problem. Now if you look at this, you can see right away that the 420, well, yeah, you see that? You see that power of 10 there, that 0? And do you notice 10 has the same? Exactly. See, we would say this is 420. This is the whole number. This is what we think this is what we're dividing. So when we think of dividend, it's this number that's the dividend. Okay? The dividend is the whole number part. Now we're going to go ahead and draw a pictorial to show this. So let's show 420. So we'll make these 100s. So that way it'll show the 400. And we'll do one a little bit tinier. 10. And then there's 10. Now basically this is just, again, a picture showing this. You may be required to do this on a particular exam. You never know. And so we're going to go ahead and divide this by, of course, 10. That's kind of the goal here, to see what happens. Now think of it this way. Now 100, if we do this in pieces, 100 divided by 10 is 10. So we'll come over here and put our 10 here. And again, we have 4 of these. So we could do 10, another 100 divided by 10, all these, okay? And now you can see what's happening here. Now, hope this didn't confuse you, but we're just taking 100 divided by 10. There's 10. So we end up with 40. And then, of course, 10 divided by 10 is a simple 1. And another 10 divided by 10 is 1. Look at the picture we end up with. See, now we can see our answer, 42. Which is just like what we were talking about, how that decimal place moves. Oh, you just got to love this. Tell me it isn't true. Okay, now let's go on to another problem for a little practice here. Trying to do this quickly. Whoa, it's like the number got really large. 24,000 divided by 600. Now, on this particular problem, rather than drawing all those, I mean, we could kind of think of it like this. We have this. So basically, this is going to be equal to, let's write it this way. This is going to be 24,000. Okay, then it's like divided by 100 divided by 6. Remember this in a previous video? I know, this stuff is so easy. I know what you're thinking. Yeah, Mr. Warren, we did that because 600 is 100 times 6. So what we're doing is we're decomposing this number. And so now you can divide that by 100. Well, you guys may recall the last time, this is kind of what we were doing. Decimal place moves 2 places. Now we end up with 240 divided by 6. Again, much easier to divide this number. 24 divided by 6 we know is 4. Okay, and then we've got a 0 right there, so we've got to put that on there because it didn't have that. Now you could show, just like what we did, that visual model, okay, of doing your 100 and going through that process, okay, which we won't do for this particular problem because I'm on a time schedule and we got to move. Okay, next is our word problem. since you will have these types of problems in class on Monday, that will be a good thing that you guys know how to do these. So here, let's take a look what we have. We have, where's my pen? Come on. Wonder if blue would show up. Nah, none of these would really show up. They're just not bright enough. Not unless I want to go, I suppose if I went like this, I could get another color like white. That would be kind of cool. And go back to full screen. Okay. Okay, so a stadium holds 50,000 people. Wow, the Qualcomm, I think, holds about 72 or 73,000. The stadium is divided into 250 different sections. I don't think they normally have that many sections, but that's a lot. How many seats are in each section? So you can see this is, I can already see, my mind's telling me, whoa, this is my whole number. Whole number, just like that objective. Okay? And I'm looking for those dividing by 10 patterns. So I see that 50,000 right away divided by, right, 250 different sections. This is so I can determine how many seats are in each section. Come on back. And pen. Oh, I don't have my white anymore. Did I lose it? Oh, I did. Come back up here. And we'll do some blue. Okay. And full screen. Sorry, this takes a little while sometimes to do that. So 50,000 divided by 250. So here I'm almost looking at this like quarters. So I immediately see this by dividing the power of 10. I already see this as 5,000 divided by 25. Okay. Now when we look at this here, we could actually do this by simply setting up our 5,000 and divide. Okay, because 25 is going to go into 52 times. And the rest, we have zeros. Okay? Now you wonder, what did I do so quickly? That was just 50 given a 0. I'll bring down 1 0. That 0 goes up here. I bring down another 0. And that 0 goes up there. Now I have 200. I can check my work. 25 times 200. Because these two multiplied should give me back to my dividend. And when I multiply, I'm just going to put those zeros like so. 10, carry the 1, 4, 5. And I put 5,000. Okay, but is that true here? Well, yeah, this is 10 times greater. This is 10 times greater. Therefore, the same answer is how one way we can solve that. Geez, I think that's the end of. Is it? Could it be? It could be. I believe so. Now, again, the code word's so vital to your success in this assignment. So please keep that in mind as you turn this assignment in. Again, we will be doing the classwork mañana. Hey, it's been real, my friends. Adios.